Hi, so today we're doing the acid-base titration lab, and the purpose of this is to determine the amount of acetic acid in white distilled vinegar using titration. I did the pre-lab questions here, and we determined what some of the definitions are. So an analyte is a substance being analyzed. In this case, for the titration, it is the acetic acid. The titrant is a solution of known concentration that's being added to the analyte in the titration. So an example of that in this case would be potassium hydroxide. Then we determined that our indicator solution is a substance that we add in titration that will determine what the endpoint or the equivalence point is during our titration process. So what we're adding in is phenolphthalein, I believe, something, yes. And then our endpoint of titration is when it changes color, and that will determine our endpoint, and that's like the physical change, whereas the equivalence points of our process will be when we see an actual calculation of when there's an equal amount of analyte and titrant within the solution. Then we have a buffer region, which is the part of the titration where the solution can resist changes in pH while adding acids or bases. Our pKa is the negative logarithm of the acid dissociation constant. The acid dissociation constant of this acid that we're using, acetic acid, is 1.8 times 10 to the negative fifth. So our pKa would be 4.76 approximately. Then our titration curve is a visualization or a graph of the pH of the solution being titrated versus the volume of the titrant added, which is potassium hydroxide. There is a difference between the equivalence point and the endpoint. Like stated earlier, the endpoint is more of a physical change or a visual change where we see the color changing, whereas the equivalence point is the point within the solution where the analyte and the titrant are equal to each other. Like stated, the acid dissociation constant of acetic acid is less than 0, so it is a weak acid, and potassium hydroxide is a strong base. So then the fifth question, asking what the pH range for the indicator solution is, that is 8.2 to 10. So now we can go ahead and get started with our lab. I'll start by measuring out potassium hydroxide to prep for the lab. So starting our titration, I'm going to go ahead and add about 1 milliliter of our titrant. Then I'm going to swirl it. And then I'm going to record that I added 1 milliliter so far and measure our pH of the solution. Which is at 2.3. Okay, continuing. We're starting to see a little bit of pink. But it's not staying, so we have not reached our equivalent point yet. The pH is at 3.9. Still disappearing. 4.5. Hmm. 4.6. So now we're gonna slow down a little bit. Four 4.7. Okay, we're nearing our end point, but we're still not there yet. We're at 4.9. So now we're going to do just one drop per addition. Still disappearing. We're at 'We've reached our equivalence point with a pH of 8.5. So now we're starting our second trial. Our first trial, we got to 56 milliliters of added titrant and a pH of 8.5. Now we are going to do trial number 2. So I'm going to go ahead and start. So we're halfway through-ish our second trial of the titration. We're at 24 milliliters of added titrant, and it's at a pH of 3.5. It's still clear. So if we continue adding, it's now at 3.6. And we're at 26 milliliters of added titrant total. We've officially finished our second trial of titration. We ended with 62 milliliters of added titrant and a pH of 8.8. We're on to our third and final titration. The first trial ended with 56 milliliters of added titrant, the second with 62. So we're gonna go ahead, add our titrant, and then start the titration process. So we're on our third trial of the titration, and I'm noticing that the pH is increasing a little bit faster this time and last time too versus the first time than from trial 1 and trial 2. We're at 11 milliliters of added titrant, and we're at a pH of 3.1. So we're nearing the end process of our third trial of titration. So I'm adding about 1 to 2 drops per and measuring the pH. So we're at 6.2. Okay, so we're about at titration now, ending it. We're at 6.4. And we're there at 48.5 milliliters of added titrant at a pH of 7.5.